Just inside, we pass through a protective screen of coarse hairs, which prevent most of the larger particles of airborne debris from entering. Once beyond these hairs, we enter a large chamber called the nasal cavity, where the air must whirl past a series of 3 projecting shells. In here, we notice a sudden rise in temperature. All the surfaces in this chamber are lined with a mucous membrane, which is filled with capillaries, which radiate the blood's heat into the air. We will continue to find this mucous membrane until the very end of our journey. It secretes a sticky sheet of mucus that serves to trap particles and moisten the air. The mucus is slowly moved along on a carpet of hair-like cilia that beat in a wave-like motion towards the throat, where the particle-laden mucus is swallowed. Here, in this microscopic cross-section, we can see the cilia in motion. Leaving the nasal cavity behind, we enter the pharynx. We pass by a large opening that leads to the mouth. We could easily have taken a shortcut, entering through the mouth instead of the nostrils, but we would have bypassed the important warming, moisturizing, and filtering that takes place in the nasal cavity. The lower portion of the pharynx serves a dual purpose. Both food and air pass through here. Up ahead, the passage divides. Food goes this way, down the esophagus, while air goes this way, down the larynx. When air takes the wrong fork and goes down the esophagus, the stomach will simply send it back up with a burp. But if food or drink go pouring down the larynx to the lungs, it can lead to serious trouble. This possibility is reduced by the epiglottis, which is a part of the larynx which extends up into the pharynx. This flap of cartilage functions like a trap door. When we swallow, the epiglottis closes off the top of the larynx. When the food is passed, it opens up again. This action of the larynx is visible on the outside as the bobbing of the Adam's apple. Sometimes food gets past the epiglottis and goes down the wrong pipe, triggering a coughing reflex that is usually enough to force the food up and out. As we have seen, the epiglottis is an extended part of the larynx. The larynx itself is a box of cartilage that forms the passageway from the pharynx into the windpipe. Stretched across the inside is a pair of ligaments called vocal cords. Muscles are attached to these cords and the adjoining cartilage. When we relax the muscles, air passes freely through the larynx. When we contract the muscles, the cords tighten, and if we breathe at the same time, the cords vibrate, creating a sound. By controlling and changing the muscular tension on the cords, we can produce a wide variety of sounds that the tongue and lips can then shape into speech. Below the larynx is the windpipe, or trachea. From here on in, it'll be clear sailing. You may notice that down here in the mucous membrane, the cilia are beating in the opposite direction. They have been ever since we entered the larynx. Dust particles trapped here must be moved upwards to reach the pharynx. The trachea is kept wide open by reinforcing C-shaped rings of cartilage. At the bottom, the trachea divides into 2 tubes, the right and left bronchi, as our molecule enters the lung. The bronchi branch again and again, forming a tree of air passages within each lung. From the smallest bronchi branch the bronchioles, the thinnest airways. The bronchioles branch out and end in grape-like clusters of microscopic air sacs called the alveoli. In this final branching, we pass the last of the mucous membrane. Entering an alveolus, our oxygen molecule has finally met up with the respiratory membrane. It is formed by the thin wall of the alveolus. Creeping across the interior wall, we see a strange creature. It represents the body's last defense against airborne dirt. It isn't easy for a dust particle to make it this far without being caught by the mucous membrane. When it does, it's this fellow's job to get rid of it. It's called a macrophage, and it's one of the body's specialized white blood cells. This one lives in the alveoli, where it creeps from air sac to air sac, engulfing dust, soot, and bacteria. Throughout our journey, the heat and humidity have been rising. This is the body's way of preparing the air for its entry into the alveolus. It must be especially humid here to keep the respiratory membrane moist. The walls of the alveolus are coated with a film of moisture. As you may have guessed, the conditions here are perfect for diffusion.